Some properties about limits. In section 1.2, we learned that the limit of f of x as x approaches c does not depend on the value of f at x equal c. Remember, in the last example, we said when we have piecewise function, we said that the limit of f of x when x approaches to 2 from the left is 1 and from the right is 1, but the value of f of x is 0. So here, limit of f of x, if the function defined, we can replace x by c. So some basic limits: let b and c be real numbers, and let n be a positive integer. So the limit of constant number when x approaches to c is the constant number, and the limit of x as x approaches to c, the value is c, and the limit of x to the power of n when x approaches to c, it means equal to c power n. For example, the limit of 3, which is constant number, as x approaches to 2 is 3, and the limit of x as x approaches to -4, it is, I will exchange x by -4, so the value is -4, and as x approaches to 2, the limit of x squared will 2 to the power of 2, and the value is 4. Also, some properties about the limits: let b and c be real numbers, let n be a positive integer, and let f and g be functions with the limit. The limit of f of x when as x approaches to c equal to L, and the limit of g of x as x approaches to c is k. We can say now here the limit of b, which is constant number, multiplied by f of x, it is equal to the constant number multiplied by the limit of f of x, which is equal to L. And the limit of the summation, or the difference between f of x and g of x, is the summation of the limits or the difference of the limits. The limit of the product between f x and g of x equal the product of the limits. The limit of dividing two functions is the dividing of the limits. The limit of f of x to the power of n, it is the limit of f of x to the power of n.